In this video, we are going to learn about hyperbolas. So the first question is, what is a hyperbola? So our formal definition is right here, and it says, it's the set of all points P in the plane such that the difference between the distances from P to two fixed points called the foci is a given constant. Now this is kind of wordy, and we're going to show you what this looks like here in this picture. All right, so we see the blue curves right here. So it's opening in two different directions, to the left and the right. That is called a hyperbola. All right, so it's got two parts to it. All right, and if you take any point on the hyperbola and we look at the distance of that point from each of the foci, if you subtract those distances, it will always be the same number. So for example, if you pick a point, say right here on this hyperbola, and we find the distance from here to the focus and the distance from here to the other focus. If you subtract those two lengths, it's going to equal some number. Now the number that's equal to is the same as if I were to take a point down here and subtract the distance from this focus and to this focus. So the subtraction or the difference of those two distances will always be the same for any point on the hyperbola. So it's kind of like an ellipse, but backwards. An ellipse, our definition was any point on the curve was going to be the sum of the distances to the foci are the same. Whereas here the distances, if you subtract the two, find the difference, here that number would be the same. So hyperbola, we have to subtract the distances, whereas an ellipse, you have to add the distances. Now what does an equation of a hyperbola look like? Well, we mentioned the difference between a hyperbola and an ellipse is the subtraction versus addition of those distances. And the difference in the equation is represented as well by a minus sign. So an ellipse had a plus sign connecting the two different parts. Here, a hyperbola has a subtraction sign. So here we have x squared over some number minus y squared over another number equaling 1. So let's kind of explain this equation and how it relates to the graph over here. All right, so the center is going to be at 0, 0. So for all these hyperbolas, we're going to keep the center at 0, 0. All right, so that's going to be this point right here. And we see the foci are at the points 5, 0 and negative 5, 0. All right, now if you had to graph this on your own, see this box right here? All right, so this box is created and found by using the numbers 9 and 16. So if we take the square root of 9, that gives 3. So see it's underneath the x term, so that indicates the distance from the center to get to the point on the box. So if you go from here over 3 to the right, that takes you to the right side of this box. And if you go to the left 3 in the x direction, over this way, that takes you to the left side of the box. Same thing with the y squared. If you take the 16 underneath it, so you take the square root of 16 to get 4, okay, that gives you the length of the box vertically. So in the y direction, up and down, you'd have to go from the center up 4 and then down 4 as well. So if you connect all those, we now have a box that is 3 by 4, or I guess, well actually 6 by 8 technically, because you have to double for top and bottom, but it's going to be up 4, down 4, and to the left 3, and to the right 3. So if we create this box and then draw a line through the vertices, so see how we have this diagonal line going through the vertices of the rectangle. We have it going both directions. We have these two red dotted lines. Okay, those are what we call asymptotes. So I'm going to spell that for you. So it's called asymptotes, where what it does is it has the graph getting really close to that line. So see the blue graph of the hyperbola? See how it's getting really close to that red dotted line? It's going to get infinitely close but never actually reach that red dotted line. So it helps us with the graphing because we know if it's starting here at these 2 points, all right, then we know that it cannot touch this diagonal line, either of them. All right, so that'll help us with the creation of this graph. So we have the foci we mentioned, and then we also want to figure out like where do we start? Like how do we know to start here at this point and not like on the top? Okay, why would it be here and not, you know, up at 4 and facing up and down? Well, to find that out, you can find the x and the y intercepts. So to find the x-intercepts, we can plug a 0 in for y. So we have x squared over 9 minus 0 squared over 16 equals 1. When you do that, this term cancels out, because that's going to be just 0. So we have x squared over 9 equals 1. Solve for x by multiplying both sides by 9. So we have x squared equals 1 times 9, which is 9. And then x would be the square root of 9, positive or negative. So we have plus or minus 3 for x. And that's how we find this point right here. So negative 3 and positive 3. That's how we know it's going to start right there. Now we can tell from the picture that there is no y-intercepts, but to find that out with algebra, you have to plug in a 0 in for x to see what y is equal to. So if you do that, plug a 0 in for x into that equation, this would cancel out, and you're left with negative y squared over 16 equals 1. So to solve for y, we multiply both sides by negative 16. So when you do that, it cancels over here. Multiply the right side by negative 16. So now we have y squared equals negative 16. And then we can take the square root of both sides. Y would be positive or negative square root of negative 16, which is not real. It's imaginary, because you cannot have a square root of a negative number and have a real answer. So because of that, we know that there are no y-intercepts. So if you had to graph this on your own, you can find the intercepts, plus and minus 3, to know where to start. And then you can create your box by using the 9 and the 16. And you can use that to find your asymptotes going across both directions. And then we can create our hyperbola approaching those asymptotes on the left and the right side. So now that we've seen the equation of a hyperbola with the actual example, and we've seen how the different parts of the graph interact with that equation, what now we want to do is to be able to take an equation and interpret just by looking at the equation. All right, so there's different scenarios you could come across with the equation of a hyperbola. So we have two different equations here. So the difference between these two, if you notice, is what is right here, what term comes first. So here in the first, on the left side here, the first equation, we have x squared coming first, whereas over here on the second equation, we have y squared coming first. So how do these differ? How are these the same? Well, for both of these, the center is still going to be at 0, 0. And this first one, this first equation, because the x squared term comes first, it's going to be opening in the x direction, which would be left and right. So it's going to look like the one we saw previously, where it opens like this. All right. Whereas the other one, if the y squared comes first, is opening in the y direction, meaning it's going to be opening up like that, and then down like that. All right, so that would be with the y squared coming first. Now we mentioned in the last slide the idea of asymptotes being the lines that the hyperbolas approach but never actually reach. From these equations, we can actually develop or determine the equation of the asymptotes by looking at the a and the b values. So basically, it's going to be in this format where you have y equals b over ax for the one equation, and then negative b over ax for the other equation. So the b over a and negative b over a is the slope, all right? And it's not, there's no plus or minus at the end because there's no y-intercept, all right? This is just the slope times x. And the way I remember this personally is because slope is rise over run. Rise is going to be the y values. So here we take the number underneath the y. So just the b, not the b squared, but the b, that's the rise or the y value, goes on top, then divide by a, the x value right here. So it doesn't matter which equation you use, you still are going to do the same idea. The number underneath the y term goes on the top. So over here, the a is underneath the y term, so the a goes on the top, and then the b goes on the bottom. So over here, the asymptote is y equals a over b times x, or negative a over b times x. All right, so, and then a and b, the a squared and b squared is going to be in order. So the a squared term comes first, b squared term comes second. Whereas with the ellipse, okay, we talked about the a squared term is always the largest one, okay, the largest number, but here it doesn't matter. The a squared would always be the first one. Now to find the foci of both ellipses, it's going to be negative c0 and c0. All right, where c, in this case, is going to be found by doing c squared equals a squared plus b squared. So this is the same formula as Pythagorean theorem, all right, but just different context. And with ellipses, remember in the last lesson, the formula was a squared minus b squared. So it's opposite sign from what we see here in the equation. So the hyperbola has a minus sign, but the c squared has a squared plus b squared. So the signs are opposite. So negative here, positive down here. Whereas for ellipses, it was positive up here in the equation and negative down here for the c squared equation. All right, and c is the distance from the focus to the center. All right, so that's going to be your foci for this equation. And for the other equation, okay, because it's facing up and down, okay, the foci are still found by looking at c and negative c, but what's changing here is going to be the y value, which makes sense, right? If you look at this, this picture, we have the foci are going to be somewhere here and here. So what's changing is the height, or the y component, which we see represented with this these ordered pairs. Whereas for the first equation, the foci are going to be like here and here, for example. And with that, what's changing is the x value, the left and right. So that's represented by changing the x value with a negative c and a positive c. And then the other thing is that the difference of the focal radii is equal to 2 times a. So focal radii, what that really means is, let's say we had this point right here on the hyperbola. The difference of the focal radii, remember we said that a hyperbola by definition will have the same, if we subtract the distances from like one focus and to another focus, subtract those numbers, that difference will equal some constant, some number that's always the same. That's what we mean here with the difference of the focal radii. So the focal radii, a focal radius would be from like the focus to a point on the hyperbola. So focal radii would be both of them. So if we subtract both of these lengths of the focal radii from a point to the two foci, okay, that is equal to 2 times a. So we can use that for either equation, and we can use that if needed to figure out different unknown parts of the hyperbola. So putting this all together, here's an example where we can use what we just talked about. All right, so we have y squared over 49 minus x squared over 25 equals 1. And our objective is to find the intercepts, the foci, the asymptotes, and then eventually graph at the end. So to do this, for x-intercepts, we have to plug a 0 in for y. So if you plug a 0 in for y right here, okay, this term is going to cancel out. You're left with negative x squared over 25 equals 1. Then multiply both sides by negative 25 to get x squared equals negative 25. But when you take the square root of that, you have a positive or negative square root of a negative number, which is not real. So because of that, it's going to have no x-intercepts. All right, and we can actually determine that by looking at the equation here immediately, because the x squared term is the negative term. All right, so that's going to make it into a imaginary number. Now for the y-intercepts, you plug in a 0 for x and solve for y. So you plug a 0 in for x, we now have we have a 0 squared right here, so this would cancel. We have y squared over 49 equals 1. Multiply both sides by 49, so y squared equals 49. And then take the square root. So y would equal positive or negative square root of 49, which is 7. All right, so here we have a squared. Here is b squared. To find the foci, we need to find what is c. All right, so c, the relationship is c squared equals a squared plus b squared. So we take the 49, which was a squared, the 25, which is b squared, add them together, and we get 74. So c would be the square root of 74, both positive and negative. All right, which if you take the square root of that, is going to be 8.6 approximately. All right, and this one actually, to figure out the foci, it might be easier to actually sketch the graph on this to figure out, if you add this and subtract to the x or the y value of the center. So if you want, you can graph quickly here, and we'll show you the better printed version of the graph in a moment. But here, okay, if you're drawing this by hand, so the y-intercepts is plus and minus 7. So you go up 1, 2, 3, 4, 5, 6, 7 right here. Then down 1, 2, 3, 4, 5, 6, 7 right here. All right, so just a really rough sketch. It's going to look something like this. All right, so we don't have the asymptotes yet, but we know it's going to look something like that, where for the foci, it's going to be somewhere here on this y-axis. So what's changing is the y value. So because we have y-intercepts, we know it's opening up and down, which means we know the foci, you need to add and subtract the 8.6 to the y value on the center. So right here, the y component, we have to put in an 8.6 and a negative 8.6. And that gives you your foci. So here's one foci, and here's your other one up here. All right, and then for your asymptotes, if you want to create this, we could have actually, if you want to just draw this, we could have actually done that up here in the graph, because we know that the 49, if you take the square root of 49, that's 7. So we know it's going to go up to 7, and then negative 7 as well. So it goes up and down 7. You can create a little box. And then looking at the 25, if you take the square root of 25, that's 5. So 1, 2, 3, 4, 5. And do it on both sides. What we do is we create a box that goes 5 over, up to 7 over 5 this way, and then down to negative 7. All right, so something like that. And then your asymptotes, if we had done this earlier, it would look something like this, connecting the two vertices. All right, we create one like this. Not our best asymptote, but you get the idea. So if we redrew this, okay, it's going to start here and go down, approaching that asymptote, go down, approaching that side over there. Same thing on the top. Your curve is going to approach that asymptote on the left and the one on the right. So something like that would be your graph. Now to find the equation of that asymptote, we can do y equals, and then we have some number here times x. The number here, remember, we take whatever number's underneath, so 49, and then the 25. We take the y one, the one underneath the y term, we take that on the top, and then the one under the x term goes on the bottom. But we actually need just b and a, or a and b, not the square. This is a squared and b squared. So what we need is actually just the a, or the square roots of these. So square root of 49 is 7, square root of 25 is 5. So the 7 would go on the top, because that's the one with the y, and then the 5 goes on the bottom. That's the one with the x. So your equations would be y equals 7/5 x, and then negative 7/5 x. And for the graph, we already had it done by with freehand, but here is a more accurate and better graph of this picture. So we have the asymptotes, we have the hyperbola, top and bottom, we have the vertices, and we have the foci as well. So for this example, the equation was already in the correct format for us, but there are times when you need to put it in the correct format first. So here's an example where you need to put in the correct format. So first things first, we want to get the x squared and the y squared on the same side. So what we can do is we can subtract 3y squared to bring it over here. So we now have x squared minus 3y squared equals 12. And the other thing we need is we want to get this equal to 1. So we have to divide everything by 12 to make that happen. So when you do this, on this right side, we're left with a 1. And then 3 divided by 12, you get 1 over 4. So what we have now is x squared over the 12 minus y squared over 4 equals 1. And then now that it's in the correct format, we can answer the same questions we did in the previous slide. Now, working backwards, what if you were given information and you had to work backwards and find the equation? So here's an example of that, where you are given the foci and the difference of the focal radii, and we are trying to find the equation of this hyperbola. All right, so first off, realize that our c value can be determined from the foci. So looking here at 4 and negative 4, we realize that the distance from each of these foci from the center, which is 0, 0, is 4 away. Both these points are 4 from that center. So c would equal 4. And then the difference of the focal radii of 6, remember the relationship is that is equal to 2a. So 2a is equal to 6, which means a is equal to 3. So using this information, we can then use this with our equation, c squared equals a squared plus b squared, to find b. So plug a 4 in for c, plug a 3 in for a. We now have 4 squared equals 3 squared plus b squared. And that gives you 16 and 9. Subtract 9 from both sides, so b squared would equal 7. And then take the square root. So b would be plus or minus square root of 7. Now, we need to get our equation, and since the foci both are on the x-axis, what this means is that the hyperbola is opening left and right. Okay, and what that means as well is that x squared, the first term, is going to be positive. So the first term is going to be x squared because it's opening left and right on the x-axis. All right, so what that means is we're going to use this equation here, where the x squared term comes first, and then minus the y squared term. And then again, a squared and b squared will always be in this order. A comes first, b comes second. So you just plug in numbers. So 3 squared would be a squared, that's 9, that goes right here. Then b squared would be 7, that goes right here. So now we have our equation, x squared over 9 minus y squared over 7 equals 1. All right, and so for this problem, we had to use both the foci and the radii to plug in numbers to find our equation. In this next example, we do have two things that we know. We have the foci and the asymptotes, but the asymptotes are more of what we need to find the numbers to plug in. Whereas the foci will tell us more which way it's opening, as it'll tell us if the x squared term or the y squared term will come first. So with this, all right, we know the equation is going to be like x squared or y squared over something minus x or y squared equaling 1. And so to plug in numbers to figure out what goes in that equation, first off, realize that the foci are on the y-axis. So if we plot those points, it's going to be on that y-axis. So because of that, the hyperbola opens up and down. And because it's opening up and down, okay, that's in the y direction, up and down is y directions. So that means the y squared term is going to come first. So what we have is going to be y squared over a squared minus x squared over b squared equals 1. All right, so the foci were used to realize that the y squared term comes first, and then the asymptotes we can use to find a and b to plug in. Okay, so we realize that a and b, a is going to be the number with the y term, the b is the number with the x term. So when you find the slope of our equation, it's going to be a over b, the y over x, rise over run. All right, it's going to be like this. So the slope is a over b. So the equation is going to be y equals a over b times x, and then y equals negative a over b times x. So if you look here at this equation, all right, realize that 2 over 3 is going to be your a and b. So a is 2, b is 3. So for our equation, to finish off, replace the a with a 2 and the b with a 3 to get y squared over 2 squared, which is 4, minus x squared over b squared is 9, 3 times 3, equals 1. So this here is our equation of that hyperbola. So in this lesson, we've learned how the different parts of the hyperbola relate to each other. We've learned how to graph a hyperbola, and we learned how to, given different information, we've learned how to find the equation of a parabola. And that concludes our lesson for today. We will see you next time.